You're welcome to my presentation again on module 6.2, the role and importance. My summary reads that we start with introduction, AfriRes launch, AfriRes objective, AfriRes functions, AfriRes activities, expected result with AfriRes, alert system early, new road construction, standards, new types of vehicles, recommendations, then conclusion. Introduction. In the reports of their joint studies on the subject, to reinforce climate resilience of infrastructure in Africa, the World Bank and ECA have estimated that failure to integrate climate change into the planning and design of power and water infrastructure could lead, in worst case drought scenarios, to 5 to 6% drop in income from hydroelectricity, depending on the river basin, as well as sharp increase, up to 3 times the reference figure in energy expenditure for consumers. In the wetter scenarios, infrastructure development on the basis of the status quo could cause a substantial financial shortfall in the order of 15 to 130% of the baseline. Regarding irrigation, projections show a maximum income low of 10 to 20% for most basins. In wet scenarios, again, the highest shortfall will be 1 to 4%. In the transport sector, climate change is expected to result in a shortening of the repair cycle of roads, resulting in a sharp increase in expenditure for maintenance and periodic renovation. In worst case climate scenarios, road damage from precipitation can increase rehabilitation costs tenfold, while flood damage can increase rehabilitation costs 17-fold. It is therefore clear that the billions of dollars needed to close Africa's enormous infrastructure deficit risk being swallowed up in repairing the damage caused by climate variation and change, which must be prevented at all costs. AfriRes launch. Among the initiatives to adapt infrastructure to future climatic conditions, the conclusions of the study on strengthening the climate resilience of infrastructure in Africa, conducted by the World Bank and ECA, were very clear as to the possible consequences of climate change. The main conclusion is that climate change will take a heavy toll on the African road network. Following the conclusion of this study, the ECA, through the African Climate Policy Center, ACPC, teamed up with the African Union Commission, the World Bank, and the African Development Bank to launch Africa Climate Resilient Investment Facility, AfriRes. AfriRes is a network center of technical competence and excellence based in Africa. The overall objective of AfriRes is to strengthen the capacity of African institutions, including national government, river basin organization, regional economic communities, power pools, among others, as well as the private sector, promoters of projects and financial at plan/design infrastructure resilient to climate variability and change in certain sectors and to and implement the necessary investment. One of the main functions of AfriRes is to facilitate the interaction between policymakers, financiers, project developers, engineers, and scientific experts in order to develop and integrate new practices that provide infrastructure resilience to change. The scope of work of AfriRes, therefore, covers different sectors and different stages of the project planning and development process. by supporting African institutions and the private sector to strengthen their capacity to plan, design, and implement infrastructure investments that are resilient to climate variability and change in certain sectors, AFRES should achieve the following components: technical assistance at project level, awareness, dissemination, and training, guidelines, standards, and good practice, notes for investing in climate resilient infrastructure, climate knowledge and data portal, expected results with AFRES. Among the reasons, main areas for which AFRES can have real impacts on the resilience of African infrastructure to climate change and justify its complement with other related initiatives underway at the continental level, we can cite: one, bridging the gap between climatology and project design, profitability in the development of climate resilience warning systems and support for project preparation, the development of technical standards in the design of adaptation projects. The new standards are: roads are important and sometimes critical infrastructure, making an important contribution to the social and economic well-being of societies. In this context, it is essential to guarantee the availability, safety, and reliability of road transport infrastructure. This should include, in particular, and also in addition to normal operations, the planning, preparedness, response, and rehabilitation in the event of natural or other unforeseen and unplanned events, as well as the safe operation of road networks in the event of likely to have an indirect impact on the availability and reliability of operations. Preventing disasters and reducing risks with a view to reducing human losses and the economic, social, and environmental consequences due to various climatic hazards is a major concern today. Policymakers are currently looking for ways to plan, design, and build sustainable infrastructure despite the uncertainties of the future. Climate change adds a new dimension to the many uncertainties with which government and private sector decision makers must contend. The changes in sea level, severe storms, and weather trends must be taken into account when planning future infrastructure investments and activities. The resilient infrastructure withstands, adapt to an integral shock line, those caused by climate change, and become even more stronger. Now, in understanding these standards, questions are expected to arise, and in such an uncertain situation, how to plan, design, and build infrastructures that will adapt to climate change while meeting the needs of their users for the next 5 or even 50 years. The answer will be that later within the module of emerging problems in transport infrastructure. However, we can first target the early warning system and cite some construction standards that can be improved to have resilient roads. What are the early warning signs, or what are the early warning systems? New and increasingly reliable tools such as early warning systems make it possible to better anticipate and prepare for natural disasters. One condition of being able to benefit in the least developed countries of increasingly frequent and intense climate-related natural disasters on a worldwide scale. The number of these events has thus tripled over the past 35 years with increasing costs. This is the case of intense rains and floods in Africa in West Africa. Without a dedicated adaptation strategy, the average annual loss due to flooding could be multiplied by 3 or even 4. After highlighting this in 2019, in its annual report, in quote, State of Climate Services, the importance that weather and seasonal forecasts can have for agriculture in the world. The World Meteorological Organization, WMO, has chosen to focus in the 2020 edition on the role of forecast systems in disaster risk reduction. In doing this, it underlines the special situation of the least developed countries. Paradoxically, in many cases, these disasters are predictable and even predicted quite reliably. The various meteorological and sectoral models, such as those relating to floods, have developed sufficiently in recent years, many thanks to advances in research and the increase in computer capacity to achieve satisfactory precision. There is, in fact, a wide variety of early warning tools, paid or not, which make it possible to signal the imminence of various perils, such as cyclones, floods, fire, etc., etc. Their temporal scope can vary and range from a few hours for a specific event to a more general forecast over the coming month, thus making it possible to anticipate whether the season will be rather intense in terms of cyclones and or heavy rains, normal or rather calm. For LDCs and small island states, these systems are recognized as priority tools for adaptation to climate change in 88% of national determined contributions. These roadmaps submitted by each country signatory to the Paris Agreement in 2015. However, the World Meteorological Organization 2020 report underlines the geographic disparities in the coverage of countries by multi-hazard warning systems. In Africa only, 30% of countries, 18% of countries did not respond or have an early warning system at the level of all LDCs. Only 23% had it. The capacities for acquiring meteorological data necessary for the proper functioning of early warning systems are much weaker in the LDCs, particularly in Africa, than in the rest of the world. In 2019, only 26% of surface weather stations in the global program climate observing system automatically and regularly provided data there, compared to 80% in Europe. On the other hand, data acquisition alone does not explain everything. As the World Meteorological Organization 2020 report underlines, the detailed analysis of the early warning capacities of the LDCs reveals in particular shortcomings in the dissemination of alerts and in the reaction to them, not sufficiently anticipated. Thus, being able to correctly predict the hazard is only part of the problem. It's now necessary, subsequently, to transform information into action in an efficient manner. The lower development of capacities for dissemination, preparation, and reaction to these alerts can be explained in part by their lack of consideration in the projects of international donors. Focusing on West Africa, the World Meteorological Organization report currently identifies nearly $2 billion as money spent on projects to support meteorological and hydrological services. However, only 28% of them have, in quote, a preparation and reaction component. It is necessary for donors to reorientate part of their current funding by promoting a more ambitious intervention focused on disaster prevention. It is also recommended to target this type of support by focusing on the countries most at risk. LDCs in particular, with which the issues previously described are the most glaring. Donors must, on the other hand, put in place more agile financing mechanisms to respond more quickly or even upstream to disaster. It is good practice to create a so-called contingency budget line, which is not marked and available immediately upon the occurrence of a disaster, because the difficulty in quickly mobilizing funds hampers the implementation of post-disaster actions. By the time the disaster is recognized as such and the funds are released, sent to the field, and spent, their use has already lost much of the time its relevance. The mechanism of forecast-based funding, FBF, is aimed to fill this gap. It plans to trigger the disbursement of funds even before the disaster, when it appears imminent and certain indicators. Rain coming within 72 hours, for example, exceed the probability threshold previously defined between experts, local authorities, and civil society. These funds can, for example, be disbursed directly for the benefit of people at risk in target areas. For example, in Bangladesh, where this system was put in place in 2019, the average cost of flooding decreased by 30% for areas where the mechanism FBF has been applied. Of course, many of these early warning systems development initiatives in developing countries are currently supported by bilateral and multilateral donors. African Development Bank, AFD, World Bank, DFID, USAID, etc., have supported this bilateral and multilateral donor arrangement. But it is necessary to think about their sustainability over a long period of time and to take into account the need for new revenue to cover the maintenance cost of these infrastructures. It is estimated today that $500 million per year must be collected to ensure proper maintenance of equipment in sub-Saharan Africa. Among the possible options to achieve this, it will be to create public-private partnership, PPP, between the National Meteorological Services and certain private actors, who investments are more on agribusiness, aviation, tourism, so as in order to generate and paying services for these entities. Forecast of certain specific variables and with increased precision, and thus benefit from stable sites. At the same time, it is essential that the academic world work on the socioeconomic impact of these information systems in order to be able to justify the importance of dedicated budget lines. It is only by thinking of meteorological services in the long term, taking into account their budgetary stability, that they will be able to carry out their mission successfully. What are the new routes? The new routes, of course, from design to site. First criterion for choosing a durable material, then ability to meet technical requirements and expected performance, which now leads to design to deconstruct and recover. Choose material from your reuse, recovery, choose material recycle, choose materials with low impact on environmental, sanitary, all more to come. If the foreseeable lifetimes are short and the possible renewals are frequent, we choose materials and products with a label, depending on the product category, that comply with these principles, that guarantee pay particular attention to the end of life. The new routes, halfway between current automobile traffic, depending on the skill and wisdom of drivers and the movement of autonomous vehicles guided by sensors, a third way emerges: the electric road, induction, conduction, or even a catenary system like the one used for trains could well, in fact, give birth to tomorrow, to an intelligent system for regulating road traffic entirely controlled by electricity. The vehicles are connected to it by means of a movable contactor pad, which is housed under the chassis. The latter is managed by sensors and deployed only when the rail is affected. Having said this, we have come up with recommendations, and the conclusion of the document for resilient infrastructure in the Sustainable Infrastructure series of the World Bank, we propose a strategy in 5 recommendations to make the infrastructure resilient. Recommendation number 1 is start with the basics. Recommendation number 2 is strengthen institutions to foster resilience. Recommendation number 3 is to include resilience in regulation and incentives. Recommendation number 4 is to improve the decision-making process. And recommendation number 5 is to provide funding. Here, recommendation number 1, it defines and applies construction codes and procurement rules. It creates systems for a proper operation and maintenance of infrastructure and a rapid response in the event of an accident. The recommendation also mobilize and allocate appropriate funding for the planning, construction, and maintenance of infrastructure. While recommendation number 2 is to implement an infrastructure resilience approach, integrating the entire administration based on existing regulatory system. It is also to identify critical infrastructure and define acceptable and intolerable risk levels, and also to ensure equitable access to resilient infrastructure. Recommendation number 3 is to integrate resilience objectives into master plans, standards, and regulations, and adjust them regularly to take into account climate change. It is also to create financial incentives for providers to deliver resilient infrastructure services, and then to ensure that infrastructure regulations comply with land use plans. Recommendation number 4 is to invest in freely accessible data on natural hazards and climate change, make robust decisions and minimize the risk of catastrophic failures, develop the skills to use data and models, and mobilize private sector know-how. Recommendation number 5 is to allocate sufficient funding to include risk assessment in master plans and early stage of project design. It's also to develop a government-wide financial protection strategy and contingency plan. Then to also promote transparency. Thank you for your time, and I welcome all questions or any questions in areas where it's not clear to you.